Now that you've learned the different types of transformations with parabolas, we want you to be able to graph them quickly. So based on knowing what the parent function is, and you can start seeing the h and the k and the a, our hope is that you can just quickly plot those points when it's in graphing form or transformation form. It's the same thing. Okay, so we're going to go through each of these transformations. So that's what we're going to look at to begin with, is we're going to look at each of these pieces, making sure that you're confident in all of them. Then you are going to graph some very quickly, nothing too spectacular. Then we're going to graph some specifically. And then lastly, we're going to look at another form if it's not in this graphing form, and then how do we graph those. Okay, so it's kind of the process that we're going to go through today. So to begin with, just kind of recapping what we know. With our parameters a, h, and k. So those parameters are what's making our graph stretch, shrink, and then horizontally shift and vertically shift. So the values that make that happen, we're going to look at stretching it vertically. So it's going to stretch it vertically when a is greater than 1. Now keep in mind if we have that negative as well, which we'll get to, it could also be that a is less than negative 1, so like negative 2, negative 3, etc. Compressing a graph is when a is less than 1 but greater than 0. So it's between 0 and 1, so like a half, a third, etc. And why do these values have an impact? It's because we're multiplying the values. So that's what's dealing with our multiplication and our vertical stretch and compression. When we look at flipping it vertically, then a is negative. Okay, so then we're looking at here, a is greater than negative 1 but less than 0, and here a is less than negative 1. So when our a is negative, these top ones will be flipped, they're reflected over the x-axis, and then again, if it's vertically stretched, it is greater than 1 or less than negative 1. If it's compressed, it's between negative 1 and 1, technically not being 0. Okay, shifting left and right. If it's going to shift to the left, that is our h value, and that is going to be an example like x plus 3. So that's shifting to the left. If it's shifting to the right, again with our h value, that's going to be x minus 3. So again, we're going those, in essence, it looks like opposite directions because we're looking at what would we have to do to our x value so that when I'm adding 3 to it, because it's directly attached to it. If we're looking at it shifting up or down, that is our k value. If we are looking at it shifting up, that would be adding, for instance, 4. If we're looking at it shifting down, that would be subtracting 4. It's because it's on the opposite side, so it's already done that opposite operation. So therefore, it's plus, it goes up. If it's minus, it goes down. And then lastly, the vertex. I put this in the last video, but for our vertex is always just hk. So h and k is our vertex. So when we look at y equals a times x minus h plus k, h is your x value of your vertex. But if I had, squared. If I had x plus 3, h is technically negative 3 because it's x minus a negative 3. So be really conscientious about that because of how the general rule is, negative 3 is actually the h value. So making sure that you have the right negativity with h and then k as well. So now what we're going to do is we're going to very quickly graph these, knowing what our vertex is, knowing our orientation, whether it opens up or down, and then thinking about our stretch and compression. So remembering that if the a value is bigger than 1, it's going to stretch it, which means it's going to become narrower. And we're not going to use a graphing calculator. So we're going to just quickly make some graphs based on our predictions, and then we're going to look at all of these different pieces as well. So what is the vertex? What is the orientation? What is the stretch, compression, or neither? And go through them. So I'm going to pause you just for a minute and go ahead and fill in all of these. So I pulled out each of the vertex from each of them based upon where our transformations are. And then I'm going to go ahead and graph them. Now looking at our a value, we have to figure out, is our orientation up or down? Is it a positive orientation or is it a negative orientation? And it's all based on that a value. So every one of these opens up. So they all have a positive orientation. And then when I look at the stretch and compression, there's none here because a is 1, none here because a is 1, stretch because a is 3, and compression because a is 1/3. So when there's none, When you think about a parabola, it typically goes 1 over and 1 up, and then 2 over, because it's squared, 4 up, and then 3 over and 9 up. So therefore we have this nice gradual parabola shape. Same thing here, compression is none, no stretch or compression. This one has a stretch, so it's going to be skinnier. So now instead of going 1 over and 1 up, it goes 1 over and 3 up. Symmetric. So it kind of gives us our skinnier graph. And then this one is a third. So instead of going 1 over and 1 up, it's going to go 1 over and a third up on both sides. So this one's going to be flatter. And it does not have to be perfect. This one's definitely not perfect because we're just doing quick sketches with these. We'll do better sketches after these next two problems. So now here, again, I want you to finish up these two problems, please. Again, very quickly with them, but make sure you write your vertex, orientation, etc. And we get those following situations. You can always check on your calculator to make sure that you have them right, but hopefully we didn't make any mistakes when I made the video, so you have everything good. Oh, I did make a mistake. Sorry about that. Did you catch it? I plotted my vertex wrong. Let's try that again. Stretch factor is 2, so 1 over 2 up. There we go. That looks better. Okay, so again, just kind of going through, trying to get you as comfortable as you can with your A, your H, and your K. Remembering always that that A is the number that's in front, that's attached by multiplication. So these two we are going to make without using a table and without using your calculator, but what we're going to need to have is we are going to need to have graphed the vertex, and we also need at least 2 other points besides the vertex. 4 would be better, but 2 will be sufficient for now. So again, looking at what you know, think about what kind of information do you need in order to make your graph without using a table, without using your calculator, and look at that information from here. So go ahead and pause it and give it a shot. So in this first one here, my vertex is going to be at 7, -2. And then this graph is opening up. And since the stretch factor is 1, when we do a normal parabola, when we do an x squared, I know 0 is 0. 1, when I put 1 in, I get 1 out. When I put 2 in, I get 4 out. When I put in 3, I get 9. Again, I don't want you to make a table for these two, but if you look at your traditional table and then backwards, -1 squared is 1 because it's symmetrical. Those y values are going to be the same on both sides of your vertex. So now what I have to look at is from this vertex, it goes 1 over and 1 up. So from here, it goes 1 over and 1 up on both sides. And then it goes 2 over and 4 up, again, from your vertex. My vertex shifted here. So now it goes 2 over and 4 up on both sides. 2 over and 4 up. And I could, if I wanted to, go 3 over and 9 up. 3 over and 9 up because of that symmetry. And we now would have a better graph. So try that for the second one if you didn't try it that way. So for this one, my vertex is at -3, +1. And now here my stretch factor is 1/2, and this is technically a compression. So now what that's doing is that's a vertical stretch or compression. So therefore my verticals, which are my y values, are going to, in this case, shrink down. So from my vertex 0, 0, it's going to go 1 over. Instead of going 1 up, it's going to go 1/2 up on both sides. And then here, instead of going 2 over and 4 up, it's going to go 2 over and 2 up. And then instead of going 3 over and 9 up, it's going to go 3 over. Oh, I only went 1 up, not 2 up. Sorry about that. Let's fix that one. So right now, I'm going 2 over and 2 up. I knew something didn't look right. And then 3 over and 4.5 up. So from your vertex, 3 over and 1, 2, 3, 4.5 up. And then the same thing over here. If you notice, between these two graphs, this one looks just a little bit wider than this one does because of that compression of 1/2. Perfect. So now that you know how to work in graphing form, this is a form that we aren't always given, but it's one of the easiest forms to graph out of. Now we're going to move into standard form, which is more of your traditional form that you're going to see. So standard form right here is y equals ax squared plus bx plus c. And you've been working in this form, in graphing form, a times quantity x minus h squared plus k. So what we are going to look at is how can we graph without making a table when we are in this form. Okay. So we're going to focus on this equation here. So in the first problem, it's talking about what the orientation is of it. So one of the things that I want you to all see, and this is something that gets forgotten over time, do you see how there's an a value right here in standard form? And there's an a value right here in graphing form. There's a reason we use the same parameter in both of these forms. That a value is that vertical stretch, and it's the same. It also always tells you the orientation. So therefore, because our a value here is 2, we know that it opens up. If we wanted to open it the other direction, what would we have to do to 2? Make a negative, right? So therefore, our stretch factor for this equation is 2. So we know that we're going to vertically stretch our graph by 2 units. So if I know where my vertex is, if I can find my vertex for this function, then I can just look at, okay, it goes 1 over, and instead of 1 up, it's going to go 1 over and 2 up. Instead of going 2 over and 4 up, it's going to go 2 over and 8 up. But again, I have to find that vertex. And let's be honest, that vertex is the most important point in your quadratic. It's that turning point. It's the highest point or the lowest point. So we're going to go now to part C. Can you identify the vertex just by looking at the equation? So if you look at the equation, do you see what the vertex is? Unfortunately, no, you don't. However, if you start thinking about some different processes that get you there, these x-intercepts are going to help us do that. So what I'm going to have you do is I'm going to have you pause the video at this point, and I want you to find your x-intercepts. Remember from last chapter, how do we find our x-intercepts? X-intercepts are when y is 0. So remember all that work we were doing last chapter with solving a quadratic set equal to 0? This is part of the reason. We need to be able to find our x-intercepts. Sorry, your space is going to be a little tight on here. But one of the things that you're going to do is you're going to be able to factor this. If you couldn't factor it, you could do the quadratic formula. But go ahead and factor this problem and solve for x. Get those 2 x-intercepts. So my 2 x-intercepts are at 3, 0, and negative 5, 0. Go ahead and put those on. Where is the vertex located in relationship to these 2 x-intercepts? It's halfway in the middle, remember? So everything's symmetric, so I need to find what's halfway in the middle. How do I find something that's halfway in the middle? The average. The average. You could count boxes, okay, 1 in, 2 in, 2 in, etc. But otherwise, we're trying to find halfway between, which is averaging. So what I'm going to have to do is 3 plus negative 5 divided by 2. So that gives me negative 2 divided by 2. So therefore, the x value of your vertex is at negative 1. We don't know what the y is yet, but we do know our x value is at negative 1. So then, to find the x, or use the x coordinate of the vertex to find the y. So here is my function again. So if I know an x value, how do I find its y value? Substitute it in. This goes back to finding a table from the very beginning. So substitute in that negative 1. You probably would do a little bit of math as you're doing this instead of writing everything out. But when you go through that whole process, you end up getting a pretty big number, unfortunately. For this problem, y is negative 32. So therefore, the vertex for this, I'll just put that down here. Our vertex is negative 1, negative 32. So I'm going to have to scale my graph by something other than 1s. But does that make sense what we did? We found our x-intercepts. We had to find halfway between the 2. We're trying to find that line of symmetry in essence. So when I found it's at negative 1, I then had to plug negative 1 back into my original equation to solve for y. I knew x, plug it in, it gives you y. So then I'm going to plot those points, or that point. So then I have negative 1, negative 32. I counted my y-axis by 4s. So I have those 2 points. I could also find another point. Another point that I could easily find in here is my y-intercept, because we found our x-intercept. How do I find my y-intercept? Make x 0. So we put 0 in here, that's 0. I put 0 in here, that's 0. Therefore, my y-intercept is negative 30. So here's my y-intercept. And again, based on the symmetry, there's my symmetric point. Okay, so then I'm going to go ahead and graph this. And there's our graph from standard form. I did not make a table. I found my vertex, I found my x-intercepts, and I found my y-intercept with the symmetric point. Nice job. Okay, so the last 4 problems here, you're not going to do all those. This is a lot of work. You can pick any of these 4, but the one that I for sure want you to do is I for sure want you to do letter A, and then you can pick one of any of these other ones to do. It doesn't matter to me which of those you do. So I'll put all of the answers on here for the graph. I'll list the vertex for each of them, and then I'll also list what the x-intercepts are. So go ahead and do A, and then pick one of the other 3 that you want to do. So I just took the vertex and I wrote it in all the forms, and then I still have to do my A value. So here A is 1, so I don't have to write anything. Here A is 1, so I don't have to write anything. Here A is 1, so I don't have to write anything. Here A is negative 4, so I have to write that. So that one's going to have a stretch, and then it's also going to have a negative orientation. One thing to note are these 3 had really nice x-intercepts, but only this one had a nice vertex of those nice ones, whereas this one had not so nice x-intercepts, but it had a really nice vertex. These 2 just had decimals or fractional vertex. One thing to look at for this, whether or not you did this problem, you will see some that look like this. When you average, you add them. So you add the 2, and you divide it by 2. What's really nice is when you do end up having these irrational values, one's a positive, one's a negative, every time. So therefore, it's 2 plus 2, which is 4 over 2, which is 2. So that's the x value per vertex. Plug it into the original equation and get your y out. Okay, and then for each of these to plot them, so since this had a stretch factor of 1, I go 1, 1. I also have the 2 x-intercepts, so I could plot my x-intercepts as well. And then connect the dots to the best of my ability. Same thing here. I have my x-intercepts, so I can plot those on here. Or I could look at, again, its stretch factor. There was none, so therefore it's 1. This one, 2, 6. I did that again. I'm plotting my points wrong. Sorry about that. That's 2, negative 6. 2, 3, 4, 5, 6. The reason I caught that is because I have 2 x-intercepts here. But if it would have been up here, I wouldn't have had any x-intercept because that opens up. So that's kind of how I quickly caught it. But then my stretch factor is 1, and then graph. And then this last one, a half, 9, and then it's negative 4, so it goes 1 over and 4 down on both sides. And then I can look at my x-intercepts as well. 2, 0, negative 1, 0, and then I draw them to the best of my ability. Okay, so that's using or graphing quadratics when they are in standard form by averaging your x-intercepts and looking for those key features. One last quick little piece is this is your methods and meanings box. So with this, you have the 3 forms. So we just talked about standard form. We've been working in graphing form. We also have factored form, which nicely gives you your x-intercepts. But then also we have just different forms of solving quadratics. I'm not too worried about this. We've taken notes on this, but this is kind of the new information for you.